Alright, this time what I want to do is let our enemies have pathfinding. They will figure out how to get to us. So this is mainly for the guards so that they can patrol to different places, because trying to program that from scratch would be difficult. Unity has a built-in way for like things to navigate around, and that's what we're going to use today. But I'm also going to use it for, if you remember our basic enemies, they kind of just go directly towards us and they kind of like bump into stuff. If I fire a weapon, I should remember to check my volume levels on that. If I go over here, for example, they don't try and get around that block, they just go straight towards me. And so that's not a great system. Let's check. Oh yeah, desktop audio is minuscule. That's good. So I think we're actually going to, since I want pathfinding on them too, we will make it global to the whole enemy script. You know, we have this, our guards are a special case of enemies, and enemies in general all have this kind of chase behavior that they can all use. And so our pathfinding is going to be part of that, I think. So actually the first thing I want to do is, I just noticed that our menu is up when the game starts, but the game isn't paused. We could either make the game be paused when it starts, or I prefer just not have the menu and just have it go straight into the game. I never really see a reason to show that. So let's just check. Escape pauses and brings up the menu. That's good. So let's do it on the basic enemies first. So the basic enemies are, this is the prefab, little capsule thingy. And what are we going to do? We're going to make them, actually, even before we do this, let's, so the way navigation works and pathfinding works in Unity is you need two things. You need a nav mesh, which is a fancy name for like just a map of where the AI is allowed to walk and not allowed to walk. And so we need to tell the game which bits are supposed to be walkable on and which bits are not, and which walls does it have to care about. Like, you know, should the enemies, we do want them to path around these blocks here. We don't really want them to path around the weapons. We don't really want them to path around that little pipe thing, maybe not, I don't know. But either way, we specify that. And so to deal with all of that, we actually need to use a navigation, just like we have these tabs for Inspector and Game and all this stuff. There's loads of these tabs that you can have that we don't currently. So if we go to Window, AI, and Navigation, it'll probably pop up as a separate window for you, like this. No, not like that. Like this free floating thing. I like to just kind of slot it in here next to Inspector. You can kind of drag it next to that tab, and then it'll just be a tab that we can switch to. We're not going to use it. We're not going to have to keep coming back here very often. But our first job is to tell it which things are solid. So we are going to select everything that I consider level geometry. In fact, let's actually make a empty game object. I use empty game objects like folders. I will just to organize what's in the hierarchy. So if I say level geometry, is that a term that does that make sense to you? That's geometry is just sort of a common name for, like, you know, the basic building blocks of level. That's the solid stuff. Actually, it's not always solid stuff, but in our case it is. So I'm just going to control select everything that is a wall or a floor or anything solid like that where we care about collision, and I'm going to drag it all to under level geometry. It doesn't change any of its positions or anything. I really should have... Oh, damn it. I'm actually going to undo that, sorry. Because this doesn't really matter, but I hate it when, you know, I created an empty game object. It's something that's completely arbitrary coordinates. I want it at 0, 0, 0. Like I say, it doesn't actually... This won't have any practical benefit. It gets confusing. You know, you'll be looking at the coordinates of these items later and think, why is it minus 17.614 just to get it aligned? So I think that's all of the stuff. Oh, god damn it, I missed. Accuracy is an important skill in game development. Alright, so that's just for our own purposes. You don't have to do that, but it's just, I find it helpful to keep everything in the same place. I've even dragged these to be in order. And now in the navigation tab, there's this object sub-tab here. And if I select everything we want to be solid, and then under the object tab, there's just a little checkbox for navigation static. So that's us telling the game this is not going to move around. You can assume this is always going to be here. And the nav mesh will be generated based on those things being, always there. And then the next thing we'll do is go to bake. And so I'll try and explain a bit what's going on here. What you don't want really is for everything in your game world to always have to check every pixel ahead of itself to see if the route is clear, and then if you tell it to go a really far distance away, to have to check every pixel of the game world. I mean, I'm saying pixel, it's not really a meaningful concept in this context, but to have incredibly fine-grained examination of everything, every little bit of space, to do all these collision checks to find out where it's going. Because really, most of the questions that the AI is asking in that scenario, or the programming that the game's code is asking, the answers are going to be the same every time. And that's what baking a nav mesh is. It's saying all this stuff is set in stone. Anytime you need to know how to get from A to B, if we're talking about A and B, if this is A and this is B, every time anyone wants to get between those 2 points, the answer is always the same. It's always just going in a straight line. Anytime anyone wants to get from, let's say, did I just drag it into the floor? I kind of did. Anytime anyone wants to get from here to there, the answer is still the same. It's more complicated. You've got to go around this corner, but it's always the same. It doesn't matter who's asking. It doesn't matter when they're asking. It's always the same. And so because all that knowledge, all those tests and answers to those questions are going to be reused hundreds and hundreds of times, thousands of times, then we want to sort of pre-prepare our answers to that. And so that's what baking a nav mesh does. Baking is a common term for instead of this being dynamic during gameplay, we are going to set it in stone ahead of time. And that's because it will take a little moment. It takes almost no time. You wouldn't want to be doing it 60 times a second. And you see all this blue stuff. All this blue stuff is places it thinks that we could potentially walk. Now, it's highlighted the top of all these walls and stuff. We're not going to use those. We're not going to walk on those. But I don't care that it's highlighted them because we won't be stumbling into them. There's some variables here about if you really want to do a fully 3D game with platforming and stuff, then can an AI get up a staircase? You would need to set things like these jump distance, step height. That's it. That determines how big of a distance the AI can sort of jump up and still carry on a path without any special logic for them actually having to launch into the air or whatever. We're not going to bother with any of that because our game is effectively 2D. If we really wanted to we could try and find a way to make it not count these. I think there's a way to tag those as unwalkable, but we don't need to do that because it's not really a problem. So that's the nav mesh already done. If we change our level, we'll want to rebake that. And navigation view, we'll keep it there because we want to be able to switch to it any time. If we see weird pathfinding stuff, the first thing we'll do is click on navigation and see where does it think the blue areas are. And the next thing is we will open our enemy and go to the inspector, and we're going to add a component. And the component we want is a nav mesh agent. A nav mesh agent is anyone who is going to be doing pathfinding. So an active thing, these things are going to move around, and they are going to look at and care about the nav mesh. Isn't it wild that the base offset is 0.9999 and the radius is 0.5001? I don't know why Unity has such trouble just giving... I just created this. I didn't do anything to it. It just comes with these bizarre, slightly off values. I'm not going to change it because I don't really know what I'm doing. That's what you want to hear from the guy doing the tutorial. The cool thing about this is... Let's get into our enemy behavior script, which is somewhere around here. And we'll edit the chase player script, method, sorry. We have a little method for chase player that both the sort of drone-y type enemies and the guard type enemies both use. And here it is. So what we currently do is find the player's position and then find a vector to them and all this stuff and calculate what our velocity should be and make sure that we're going to the same height and everything. The nav mesh is actually going to make this way simpler for us. So the first thing actually we want to do is we need a reference to our go away please, public nav mesh agent, and as is often the case, it's not going to know what the hell we're talking about, but if I hit Alt and Enter, did it have it there? Unity Engine AI Nav Mesh Agent. That's the one we want. Nope. No, sorry, that wasn't the right thing to choose. I wanted to import. Oh yeah, right at the top, using Unity Engine.ai. So again, it's in. This is called a namespace, and it's in a different namespace. Basically, you are often not working with AI, and so it doesn't include this stuff by default, and you need to add that using line at top. And I'm going to call it nav agent. And then on start, we'll, just like we do with our rigid body, we'll say nav agent equals get component nav mesh agent. And then back to chase player. If the player exists, then let's just do, for now, nav agent destination equals just this. So that's the player's position. And then I'm going to do this special way of making a comment where you start with an asterisk and slash asterisk and end with asterisk slash. Hard to say. Just to remove all that code. All that stuff was when we were manually controlling our velocity. Now the nav mesh agent is going to do it all for us, and it's just one line of code, I hope. Let's see if that is sufficient. Is it really that simple? It seems too simple. I'm suspicious of myself. We would expect this to affect the drones that swarm in when we fire a gun, and the guards, but only when they're alerted. They won't do anything just yet, but once I... So out they spit, and if I give them a slightly harder challenge to get to me, look at that, they're taking the corridors. They know exactly where to go. And it's crashed. That's interesting. The guards don't have it yet. Yeah, that makes sense, actually. So we gave a nav mesh agent to the little guys, but we didn't give it to the guards. That was fine right up until the guards saw me. And when the guards saw me, he tried to run his chase behavior, and his chase behavior made reference to a nav mesh agent. He doesn't have one. So don't edit the instances here. But actually, if you click on one, it will give you a button to open the prefab. We want to do that. And we'll add component and give them a nav mesh agent too. And we haven't changed anything on them yet. Let me just check. The guard's speed is 0. Is that intentional? Did we do that for a reason? Is that because we wanted them not to chase you for now? It doesn't matter right now, I'm just curious. Okay, so let's just check that fixed the crash. I'll intentionally get myself seen. Oh, they do follow you. Let me just pause now and see, what does it think the guard's speed is now? Like that particular guard. That particular guard speed is 0. Is that kind of weird to you? Oh, no, okay, so, right, this is... I don't know why we set it to 0. It probably was we wanted them to be routed to the spot. But that is getting ignored now because they're using nav mesh agents to chase us. One thing we could do is we could actually have a line in there and say that nav agent.speed equals speed. So if we preferred, we could just set the speed in the inspector now because we have this nav mesh agent thing. Since we already have a variable for speed, I'm just going to have one copy of the other. But yeah, if that gets cumbersome, we can change it. So that should make it so that guards don't chase us anymore. Yeah. And actually they don't face us either, but that's okay. So guards are going to chase us. That we will fix that. I think the only reason they didn't is because maybe for testing reasons. Anyway. So that was pretty good. That was pretty easy to get working. I think there's a little bit of a flaw with it because I see some slightly strange behavior. If I fire and these guys will chase me. Like those two guys are way faster than the others. They got kind of pushed a bit by the others, and if I bump into folks, we see some slightly strange results. They seem to like drift forever and stuff like that. I think this is because they have a let me close the canvas here. Let's look at an enemy. They have a rigid body, and the rigid body is this physicsy thing that's supposed to govern motion. And what we were doing before is we were manually feeding some velocities and stuff to the rigid body to make it behave the way we wanted it to. Now the nav mesh agent is doing everything, or trying to do everything, but I think the rigid body is interfering with it. So the thing I did in my test was I just removed the rigid body, which is fine, and that fixes it. But if we ever did want the rigid body back, so the scenario I'm thinking of is, for most of the time, if everything is a nav mesh agent, they will very intelligently swarm around and follow paths and navigate like thinking entities, which is great. But if we ever did just want to smash, damn it, I gotta remember to bleep that. If we ever did just want to smash them into a wall, like knock them flying, then we would need to we'd need physics back. And so I'm going to try, rather than removing the rigid body, I'm just going to, right after we get the reference to rigid body, we will say, oh wait, no, why would I do this here? I don't need to do this here. In the prefab, I'm going to check this box that says, is kinematic. Kinematic basically means not physicsy. It's not a word you hear in other contexts very much, but it basically means we're going to control it. Don't worry, rigid body, don't worry about anything. We are going to control all the motion. You don't need to simulate anything. And I think of it as a way of basically turning the rigid body off. That isn't quite true, because I think collision is still a thing, but that's basically what we're talking about. So did I do that on the regular enemy or this enemy? Okay, this is the guard, and we're going to check is kinematic there. So it should be checked on both of them now. Yep. Let me see if that fixes it by itself. So the reason that's better than just removing the rigid body is that if we did want physics, then we would be able to just... Yeah, so now we're not seeing that weird thing where two of them went ahead. It's funny, isn't it? They go in this sort of like... I think of that as like a braided pattern. It's sort of... oh, look at the way they flow. It's really cool. Because Unity is doing a lot of work for us here. Like, I've coded things like this myself, and with nothing like this level of sophistication, and it took ages. And Unity's done it all, and like we wrote one line of code basically to do all of that. And so it's doing stuff like, I'll just get out of this enemy. They are sort of respecting each other's distance a bit. Like, they're not desperately bumping into each other and bouncing off each other all the time. They're sort of trying to keep a respectable distance while also hopefully getting towards their goal, and also smoothly going around corners. And there's all kinds of stuff going on under the hood there that we didn't have to write, and it just works, which is lovely. That's the great joy of using an engine that's a fully built tool set that's gone through a lot of development and that you didn't build yourself. There are advantages to building your own stuff, but I'm never going to do it. It's way too technical for me, and I think it's way more work than it's worth. So yeah, I think our behavior is way nicer. And yeah, guards don't follow us right now. I think let's... I'm still sort of umming and ahhing about whether it makes sense to have our own speed variable when there's one on the nav mesh agent. I think it does. I think we're going to still have our own speed value because this whole panel is kind of configuring the enemy, and let's leave all that in the same place. Let's just have a nice central place where we configure the enemy stats. And I am just going to give them a bit of speed, just so that they do chase when they see us. Very slowly. Yeah, it's kind of cool. So they are omniscient. They don't have to see us to know where we are. As our location changes, their path changes. We could fix that if we wanted to, but it's probably above our pay grade at the moment. So that is chasing behavior is done basically. But the other thing we wanted is for guards to patrol, and so to do that, I don't want to teach them to like read their environment and intelligently come up with optimal patrol points. Writing that kind of AI is again above our pay grade. And it's also, sometimes it's a losing battle. Like you have all that sophistication and complexity, and the end result of it is that you can't control the AI in the way you want to, and so you can't create the experience you want to give the player. It's often better, much, much easier, and actually better in the long run to just sort of hand build things and do it in a find an intelligent midpoint between completely pre-scripted and the game unfolds the same way every time, and completely dynamic and adaptive in a way that becomes chaotic and very difficult to control, and actually really doesn't often lead to good gameplay, in my opinion. You more often get that somewhere in the middle ground where there's lots of dynamic elements, but the designer has had some control over, what can and can't happen. And in this case, I'm going to create a new game object, and it's going to be a sphere. And if we go to scene view, I'm going to change its y coordinate to 0 to get it on the ground, then drag it around. And this is just going to be like a patrol point, or something that the guards are going to visit every now and then. I'm going to remove this collider. It's got a collider on it at the moment. I don't want them to bump into this. It's actually going to be invisible eventually. For now, we wanted to see it because it's useful to see it. I'm going to add a component, a new script, and I'm going to call it nav point. And basically, all this script is going to do is just sort of put us on a list. You know that we have this references class. If I hit Control-T and type the word references, then I can jump to it. And I'm going to create a public static list of nav points. And I'm going to call it nav points. And I don't know if you remember this, but when we're dealing with lists, this is not enough. We've defined a variable here, but we haven't created the list. The list is like a bit of paper that you're going to write stuff on. You have to create the bit of paper when you create it. So we say equals new list of nav points. Brackets, semicolon. So this starts a list. We haven't added anything to it yet. And then all nav point itself is going to do is on start, it's going to go to nav points.add this. So I think we've used this before. The word this just means this script, and it doesn't mean our game object. It doesn't mean our transform or our position. It means the nav point, this particular thing. Basically, this refers to this. And that will work, but I'm actually going to show you, because it's such a common thing, I think it's worth knowing that the way I add and remove things to lists are super useful to keep track of things. If we don't already, then we'll probably end up having a list of enemies here, like a list of every enemy in the game, a list of every enemy spawner. We'll definitely make a list of those. When you do that, if you just add to it on start and nothing else, if this thing ever gets destroyed, then you'll have a invalid reference in the list. There'll be a crash at some point because of that. So we can remove ourselves from the list on destroy. There's an event called on destroy, but I'm not going to do that. I'm going to change this one. Instead of start, I'm going to change it to on enable. And then the next one I'm going to do is I'm just going to write on disable, and it auto-completes. And then I'm going to copy and paste this. And instead of add, I'm just going to write remove. So this says on enable will run on start as well. When we start, on enable will run a bit before that. And on disable will run when we're destroyed as well. Both those things happen as in both the creation and the destruction process, but also if I just reach in and if I just unchecked this box at runtime, that would take us off the list as well. And so that is good because it covers all bases. Every way that the thing can get destroyed, on disable will always be run. Every way it can get created, on enable will always run. And it also has this additional functionality of while you're running the game, you can uncheck things and recheck them to toggle them on and off and see how the game reacts to that. And that's really useful. And it's just in general true that everything else about Unity, when something is disabled, it acts as if it doesn't exist. And so your script should try and match that as best you can so that you have behavior that kind of matches the way Unity expects it to work. So yeah, on disable and on enable, I'm just going to write the word private here. You don't need to do this, but it just matches. If you don't write anything, it assumes it's private, but I just want those to look nicer. So we have a list. and these things are going to add themselves to it. Next thing we want to do is let's find the guard behavior, Control T, guard behavior, and let's, just to test that this is working, let's have them tell their nav agent that its destination should be references, slightly misspelled that, references dot nav points, and then let's just go to the 0 element of that. The 0 element of that and get its position, because we need to give it a position, not just a nav point. So this is not what the behavior will want, obviously. This is going to tell every guard to go to the first nav point as soon as the game starts, but we shall see if it works. And then we can make that more sophisticated from there, once we know it's working. So I'm going to name this thing nav point, and before we go any further, I'm going to drag it into our project folder to make it a prefab. And now I can duplicate it, and so we'll have more than one of them. There's two. I don't know which one will end up being the first one according to the game. So let's see. Yeah, they're all going to that one in the corner. It's quite satisfying to do this. I wonder what happened when he gets there. He turns around. Is he going to spin forever? Yeah. Well, that's probably just their natural spinning behavior, isn't it? That's what we already asked them to do. So that's kind of nice. It works pretty smoothly. It was a trap. Okay, so now let's make a bunch of these. I will click it again, duplicate it again, duplicate, and that first one, I'll duplicate that, and just put it in all the corners. They don't have to strictly be just the corners, but that kind of makes sense in terms of what I want the guards to do is go to a random one. So they're going to, when a guard arrives here, they're going to pick another random one. It could be the next one over, it could be your one all the way over here, and then they'll figure out a path to get there. And that way you'll have a sort of random searching behavior of the guards. So it's sort of like, if these are points of interest, like they've on their roster of things they've got to check every night, each time they get to one of them, they just randomly decide, I'm going to go check out that other one. I wonder if anyone's there. And so what would that behavior look like? So we don't always want to path to the same nav point, do we? This 0 is not a good idea. What we want is an integer, a whole number, for a random nav point index. And how should we get that? Well, we want it to be a random number in between 0 and the maximum number of nav points that there are. And so it will be a random range, random.range. In brackets we'll say 0 for the lower limit, and then for the upper limit we'll say references dot nav points dot count. Count is, if the list has 2 elements in it, count is 2. The indexes of those elements will be 0 and 1. There won't be an element with the number 2. But we're okay here because of a weird little thing, and I'm going to write it in a comment because it's weird. And it's just one of those little gotchas that can trip you up. When we give random.range float numbers, they can go all the way up to the max. But when we give it integers, it will never choose the max. So it will never choose count, because I just told you that when there's 2 elements, there is no element 2, so it mustn't ever choose 2. So we're feeding it in 2, but we don't want 2 back, ever. And you can verify this when you mouse over range. It will tell you, return a random integer number between minimum inclusive, it can be 0, and maximum exclusive, it can't be the maximum. So that's why we don't need to subtract 1 from this. I think an intelligent question when I wrote that line would be, why don't you subtract 1 from that? Because you're not allowed to use the top value. And the answer is because when you pass in an integer, for some reason it doesn't use the max value. I think actually the reason that's the case is purely for this case. This is a very common thing, is you want to find a random element of a list, and the count value of a list is not in the list itself. It's one above the thing. And so for convenience, they made it work this way. If it was me, I would have made it consistent, because I think that's more important. But here we are. So now we want not 0, but a random one. So this is still only on startup. It's not going to happen regularly, but let's just check that that worked, and that guards hopefully go to different nav points. See if we can guess which one they're going to. So this guy, I think, is going to this corner. That one's already arrived. I think this one's going to the same corner as this guy. I made them too slow. This is kind of a good patrol speed. Yeah, he's going to arrive there. So 2 of them did pick the same one. We've got 8 options. That's not too surprising. We actually, because we have an in-game menu, I can just start again and see what should unfold differently. Oh no. Oh, we've got a problem with our pausing code. Yeah, they're going to different ones this time. We made a random game. It's a roguelike, basically. So that's cool. But now let's not just do that in startup. Let's make it a method unto itself. So if we say void, go to random nav point, then we can just copy and paste all of this into there. And we will do it on startup. That'll be the first thing that the guard does, is go to a random nav point. And then the other time we want to do it is, remember, this is not the code that moves us. We're not running this code all the time that we're traveling. We just run it when we need to choose a new destination, basically. I could have called it that, actually. And so, to check, so when we're alerted, we're going to chase the player, and that's its own nav thing. So we don't want to do this when we're chasing the player, but when we're not chasing the player, what we want to check is, have we arrived? Like, when we arrive at a nav point, that's when we want to choose a new one. We're going to go to one from the start, and as soon as we arrive at that one, we want to pick a new one, and then every time we ever arrive at a new one, we'll want to pick a new one. And so the code for that is navagent dot remaining distance. If navagent remaining distance is less than, let's say, 0.5, that's half a meter. That's basically we're bumping into it. You can make it smaller than that, but don't make it 0 because it'll never be less than 0. And checking whether it's equal to 0 is also a bit dodgy because you might miss the frame on which that happens. So it's good to have a little safety margin there. Where remaining distance is less than 0.5, then go to random nav point. I think that is it. Let's see if it works. So they're gonna. He's facing rather weirdly, isn't he? I'm not sure why he's looking in that direction. They're going to some random nav points. And now they're turning around and going to other nav points. It's actually created quite a bit of a tight spot for me, hasn't it? I can slip by now. Oh no, I can't. Shit. Okay, the alarm's gone off. Okay, that's our gameplay. That's what it's going to be like. And that kind of worked. And look, this guy's hounding me now. The other ones are still randomly patrolling, which might be something we want to change. But their random search behavior is working pretty well, I think. And it's kind of cool because I didn't, plan for this really, and we didn't code it specifically, but you can kind of read their intent from the way they're facing. This guy's still, they list a bit to the right, don't they? I'm not quite sure why that is. But yeah, you can sort of guess where they're going from the sort of organic way they path. Like, you knew this guy wasn't going up there, right? He was going to, partly because he's alerted, and that's not what they do. Yeah, so that's pretty cool. The other thing we should do is just make it invisible. And so we can just uncheck mesh renderer in the prefab here. And then that will look fine. We can't see him anymore. And I was spotted, so everyone flooded in. Yeah, that's good. The only thing I'm worried about is, like, what if we can't see it now as the designer? We don't see where our nav points are. So I might just do a little bit of... We might just make that part of the script. So I'll open the prefab again, I'll re-enable the mesh renderer, and then let's just have our script do this for us. So I think this should be on start. Yeah, we only want it to happen once. and we will just do if I just do get component mesh renderer brackets, then I just say dot enabled equals false. So find our mesh renderer and turn it off as soon as we start. So if I go back to our scene view, now we can see them all, but when we play, I'm hoping they'll disappear. Yeah, nice. Okay, cool. I think we're done. Yeah, so we've got the bones of gameplay here, right? I've got to avoid these guys. When they see me, new problems are created for me. And the next things I want to do are have a level that we can complete, so that have a limit on how many of these guys are going to show up. Like have probably just one wave of enemies, but it could be more. Oh, look at that cool shadow. That was cool. And then once you can complete a level, the next thing we need to do is figure out how do we make level 2. Are we going to hand build it? Are we going to randomly generate it, or what? And I don't know yet. We'll figure that out when we get to it. And the other thing I was thinking was, so the concept of this game, the sort of design idea behind it, was just a fairly idle thought on my part when playing The Last of Us, which was that I'm not engaging with the action gameplay in that game because I enjoy the stealth gameplay, and as soon as that goes wrong, I just reload a save and do it until I get it right. So this game is designed to avoid that problem, where if we're going to make an action game and a stealth game, we want everyone to experience both. And so my idea is that the stealth game happens first, but you have to trigger the alarm, basically. And that's how I phrased it. I knew that there would be player resistance to that idea. I know we're not going to have very many players for this game, but even so, as a concept, you want to be wary of anything that kind of rubs players the wrong way. There's some things players are very sensitive about, and the idea that the alarms, I must set off the alarm, but I don't want to set off the alarm. So I thought about that. My idea for framing it, and not just framing it, but actually changing the mechanics, is I think the guards are going to be shielded. So they'll be, when the power is on, the guards are invincible. You cannot take them out. And so you're not setting off the alarm. What you're doing is finding the power switch and shutting down the power. And when you do that, all the guard shields come down and you can kill them. But also, as soon as this place loses power, there's a security alert and they send in all these drones. And so that way it frames it as like a player positive thing. Like you are doing this as a means to an end. You need to take out these guards. The only way you're ever going to be able to do it is if you switch off the power. And I think that will make players more accepting of that idea. But yeah, we'll see how that pans out when we get to it.